Pakistan's underdeveloped smelting tech means most of its silver is imported. So, this Pakistani workshop scraps compressors to extract their silver. It only takes simple smelting to get pure silver. This fashionably dressed young man is busy cleaning the compressor's exterior, removing various parts from the cylinder block, and even knocking off the attached copper pipes to collect. These small copper pipes add up and are worth good money, but the copper wire in the compressor is the real prize. He clamps the compressor and cuts the steel plate with a semi-automatic cutter, a Pakistani master's specialty. With machinery, handling large batches of compressors is effortless. Then, workers remove and stack the motors, setting the remaining casings aside. From this mountain-like pile of casings, you can see how efficient the Pakistani masters are. These cast steel casings had a new discovery from Pakistani workers: silver ore on them. Silver's hidden in the solder joint between the copper pipe and the canister. To miss none of it, the master precisely cuts the solder ring off with a torch. It's as satisfying as removing a corn with a scalpel. The cut-off solder rings are piled together. To separate them, they must be heated with a blowtorch. Just heat the iron sheet red hot, tap it a few times, and the solder ring drops off. Collected solder rings are poured into a plastic basin, and the Aqua Regia is measured. A warning: this is risky to handle bare-handed, so do not imitate. Pouring the Aqua Regia into the basin releases a pungent, overwhelming smell. We need more acid solution for a complete reaction. It's like the saying, the rougher the seas, the pricier the fish. This is a real battlefield. Stirring speeds up the reaction. It's done when smoke clears. The solution is now dark green, with all the silver dissolved. Discard the remaining residue. Next, add sodium chloride and iron sheets to the solution. Shaking it a few times speeds up the silver chloride's reduction. Using iron to reduce the silver chloride is the cheapest way. After rinsing the iron sheets, the silver chloride at the bottom will be gone, leaving only solution. This solution contains much copper chloride, along with the silver chloride. Then we add a catalyst and metal sheets to continue reacting. These metal sheets are probably aluminum or zinc. After repeated shaking, their surface turns into a brassy color. This process is simple. Pour off the top solution. The silver settles at the bottom. Unlike sponge gold, sponge silver is grayish-white. That's quite a large amount in this basin. The sponge silver is filtered with a cloth, drained, and packaged into a plastic bag. This bag is so big that the crucible can barely hold it all. Since the crucible is preheated, it's placed directly on the furnace for smelting. The flame from the furnace is green. Perhaps the experts watching can explain why. After smelting, the sponge silver has completely melted. It appears free of impurities. Once a release agent is applied to the mold, the silver can be poured. One crucible can forge 4 silver bars. The only downside is they're not traditional ingots. Who knew ordinary scrap recycling held such a big business opportunity? Each bar is at least half a kilo. Now calculate its worth in rupees.